kind of why Docker in the first place. Then, I'll give like a whirlwind tour of Docker, which will probably confuse you. And then we'll go into like a little bit of like how Docker is working underneath. And then we can get into like actually using it. So it just takes there's a few different concepts here. So, just bear with me. It does take a little bit of time to get oriented. So, just in terms of like, what does Docker do? Docker just sets up your environment, like your coding or like the environment to run an application, right? Which may not seem like a big deal, but if you think of something like a blog, right? Like for instance, this is a piece of software that lets you, easily run like a production grade blog. Like say you could, set this up on AWS or something. If you think about like if we want to just like use Ghost, right, which is this blogging software, like think about everything we would need to install for this, right? Like we'd have to have like some sort of backend, right? And that would be like Python, and then you would need the right version of Python. You would need a database, right? So that might be like Postgres or something like that. Right? So you'd have to make sure, as you guys know through working with AWS, we'd have to set up Postgres or install it properly. You need some sort of front end, right? So that would be like JavaScript, right? You'd have to, and React. God forbid they use Node, right? There might be Node involved as well. And then each of these things would have to be compatible with one another, right? We'd have to worry about, of course, like Mac versus Windows and the right version of Mac. Sometimes you do still have to worry about that a little bit, even with Docker, but hopefully that could be automated. And then, of course, there's the setup. You know what I mean? Like you'd have to, if we have this blogging application, and we have, maybe there's users and there's authors and there's posts and there's, maybe there's like a sequence of stories. Well, you'd have to run the migrations, right? And of course, there's all the Python libraries, right, that we would have in our requirement set of text. So you'd have to make sure you do that, right? Install the Python libraries. So all this stuff, right? All these steps just to like set up an application, right? Like Docker can be used for that. And then, one of the reasons why this has become so important is because if you think about the development workflow, meaning like when you work on a dev team, how you start developing things, right? You'll be, this software developer, and maybe you upgrade like the version of Python that you're using from 3.10 to 3.11, right? When you're done, everything's working, you then need to push to production, right? You need to push your code to AWS. And what you don't want to occur is like you just upload your code, push your code through GitHub or something like that, and your code relies on 3.11 and this is running 3.10, and then all of a sudden everything in production breaks, right? The other thing that you don't want is, let's say you on your computer is using 3.10 and you're using, or 3.11, right? And everyone else is using 3.10. And because of that, when you push your code to GitHub and the rest of the team clones down and uses your code, right? Your code works fine on your computer, but it breaks on everybody else's, right? Because your development environment isn't consistent with everybody else's, right? So making sure that, like, basically automating the setup of an environment to run an application is really important for a dev team, right? Because as you all know, by having coded for the past 4 months, these environmental issues can really be hard to debug, right? It's like all of a sudden we're getting some error in the code base, and the reason why is because there's some inconsistency between, my development environment and somebody else's. And especially what's even more dangerous is, well, production goes down. And why is that? Because there's some inconsistency between how I was developing this and what exists in production. So the more that we can kind of perhaps give instructions, and we'll see, like set this up so that all these steps that are needed for some sort of application are just encoded and are automated for us, right? That's very useful. Okay, it's useful for like just developing things quickly. It's useful for when working on a dev team, making sure everybody's working with the same environment. It's useful for when pushing to production, right? Making sure that my development environment is as similar as possible, right? We're using all the same technologies as we are in production, right? Or coming very close to it. Okay, so that's why Docker is really useful. I have this stat I think at the beginning that it says in 2020, 35% of programmers said they use Docker, placing it above AWS and using a Mac, right? So it's like this is a very popular part of a tech stack. In terms of, so now we get like kind of why Docker. We can get started with it. To do that, let me just do this one thing. Yeah, so it's go. I just have to make sure I have the right version. So we talked about using this piece of software, Ghost, right, which sets up a blog and probably requires a bunch of different tools to get started. So we can, by the way, you can run Docker from any folder. I just make sure, I have it already installed. I can make sure that it's running by, looking to see that this little boat thing is there. If it's not, you can just, on the Mac, you can just do like Docker and on it, and then make sure this boat thing is up there. But now I should be able to type in the word Docker, right? I'll just cd into this directory, but I can type in the word Docker, and you can see that it's right. I get a response. It's coming. We want to do this: download an image from a registry, and this just means basically download, like kind of like git clone, right? But for Docker. So do Docker pull, and I want to do Ghost : 4.8.0. This is the version 4.8.0, and I already have it, I think. So you can see images. You can see it's pulling from library Ghost. It's not so dramatic because I already have this image here. I can see it if I do Docker image ls. Here's my Ghost image. So this is like I basically cloned it down. And like I said, we'll go through all these commands again. This is just like a very quick tour. And then I'll do, if we want to boot up this application, I'll do Docker run Ghost 4.8.0 and run this. And notice, this is kind of what I wanted to show you. Notice the work that has to go into this, right? It has to create all these tables. It says it started the server, right? It sets up these permissions. And now scheduled a job that I guess will run every week or something like that. And then eventually, maybe it's already here, it says it's running on localhost 2368. Now this is going to break. Okay, so this currently breaks. And the reason why is because with Docker, as we'll see, isolation is really important. So this is kind of like isolated behind a wall, this application. And in order for me to have access to it, I have to expose the port. So I can say something like the host port, I can say like 9999 goes to 2368. So basically, we'll get into this in a second. And now I should be able to go to localhost 9999. Okay, and here's Ghost. All right, so maybe you can just start to see like kind of how useful something like this is, right? Like having the necessary database, having the tables all set up for me, having the server start up for me, having all the Python libraries automatically installed for me, right? And then just being able to get going pretty quickly. So as we kind of saw right there, there's a few different things that probably is confusing at this point. One is, we did this Docker pull thing, and we downloaded what's called like an image, which we probably don't understand what that is. So the first thing is like, what's an image? And then when we boot up Docker, we need to boot up a container of that image. So whatever that means. So we say like we boot up a Docker container. So you have to think about that, and that's kind of like running the image. And then the other thing that we saw is just like that for whatever reason, Docker is performing this degree of isolation. So like why and how does that work? Like why can't I just go to like localhost 2368 and access it? And so I had to do this weird thing where I do -p to like get access to that port 2368. Okay, and now I can go to 999 and it works. Okay, so that brings us to the next part, which is like why Docker exists in the first place, and like how it was developed, right? How it works. So when understanding these technologies, and if someone asks you about it, a good technique is just to think about like what did the world look like before this technology was invented, right? So before Docker, how would we make sure that the application we set up would just run perfectly, meaning that like all the environmental dependencies, everything that we needed for something like Ghost to run was consistent between your environment, every other developer's environment, and production. So a way to do that is essentially start from scratch with a virtual machine. So before Docker, people use these things called virtual machines. They still do sometimes. What's a virtual machine? You can see I have one here. Here we have, a Mac, and the virtual machine is Windows. Okay? And just to get some terminology out of the way, right, the Mac is the host machine, right? This interacts directly with the hardware, the host, and then the guest is Windows, right? The virtual machine operating on the host. Okay, so this is our host, this is our guest. And this is like how we would, and you can imagine, like we could just like write out on a Word document the instructions to then get Ghost set up, right? Like download Postgres, download this, and we just, by starting from the very, very beginning, we would, and then proceeding with a series of instructions, we could basically ensure that our environment is perfectly set up. Okay? And if you think about why something like this works, it's because we're basically starting with like this clean environment, right? Like there's nothing, we're starting with a fresh version of installation of Windows and then slowly building everything up. And this makes sure there's no other weird pieces of software that are going to like cause conflicts. So this does work, using a virtual machine, right? And this is what people would previously do. But, an issue with the virtual machine is that, well, one, it takes these extra resources to like have Windows running. And, it takes a minute to like actually boot up Windows on your Mac. So that's annoying. Other issues with it is, say you have multiple applications, right? Like say we have like Ghost is our, blogging platform, but then we also want like a chatbot, and we want to make sure that, our chatbot works perfectly as well. Well, then what would you do? Like the safe thing to do would be to create a separate virtual machine just for the chatbot. So you could imagine like for each service, creating a separate, having a separate virtual machine. So that would be like for the blogging platform and 2 for the chatbot. And now like this is an issue because, we're wasting space, but we're wasting resources, right? Like we have 2 instances of Windows running. Maybe like there's some shared technologies between them. And now we're like installing Python twice and having it on each one of these machines. Maybe both of them require the same database. We're using those things twice. So it's like, as we want to, and you can imagine there could be more than just 2 applications we need to run, right? We're starting to really waste some resources. So the goal of Docker, right, is to create an isolated environment, right? That's the same, so that we kind of can ensure things properly work, right? We're not having these conflicts, right? We're basically starting from like a clean environment and slowly building things up, while not consuming all of our resources, which is, and being inefficient with our like space and speed resources, which is what something like booting up a separate virtual machine, right, for each application would do, right? It would be pretty inefficient because there's probably like some shared underlying, software that ideally could be shared, but like, how do we, if we make it shared, then it feels like it's not isolated anymore. So how do we accomplish that? So Docker uses two pieces of technology to do this. The first one is this Union File System, and this is really the main one. Okay, so Union File Systems, they came like from the days of CDs, right? Like the things that you would insert into your computer. And here you can like see my example, which is, let's say, one feature of Union File Systems is that it looks like things that are located in different places can be under the same folder. So here you can see that, right? We have Chamber Secrets. This is coming from a CD. We have Source Server Zone. That's coming from a hard drive. But like, even though they're in two different directories, right? This fancy, right? It doesn't seem so special, but it can make it appear as if they're both under the same folder. Another thing that's probably even more relevant to us is that, let's say that I decide, I borrowed Chamber of Secrets from my friend, and I decide I want to edit the first page of the book, okay? What the Union File System will do is it won't actually edit that first page, okay? Instead, what it will do, it will just see that you want to edit it, and it will just make a copy of that first page, layer it, and put the edits here. And then when you read that first page, it will read your copy, your changes, and everything else will stay the same, all right? So the benefit of this is my friend still has his book untouched, yet I get my change. All right. So that's a Union File System. A Union File System allows computer contents to be seen under a cohesive directory, even if they live elsewhere, right? That's the first thing we saw. And the contents are read-only. Any changes made are performed first by copying the relevant file and then making an edit. Okay, so Docker uses a Union File System so that when we say have, let's say we have our chatbot, and our chatbot uses, some JavaScript, and it uses, Python, 3.10, and then we also have our blogging application, right? And that uses maybe JavaScript with some sort of change, I'm not sure what, and it uses, but it also uses Python 3.10. Well, the parts that are the same here, they can be shared, right? And let's say our chatbot needs to then change some component of Python. How will it do that? It won't actually change it, right? It won't actually change the software. Instead, it will perform a copy on write on the necessary file and change the copy. Okay, so what does that mean? That means we can kind of be free to change any shared libraries, and it won't affect the other application, right? Me changing something over here won't mess it up over here because I'm not actually changing the original. I'm making a copy before applying the change. Okay, so you can see that when you pull down when we do Docker pull down Ghost, each one of these things are the layers, and it pulls down this series of software, and then if any of these layers differ between applications, it will, just change that layer, but not actually change the underlying, anything else that it relies upon. In fact, when you boot up a container, so let's think about this. We have this piece of software. We pulled down an image, right? Because we pulled down Ghost. And then let's say we run Ghost and we start creating, a new blog or something like that. When you do that, it's not going to change anything in the image, right? Which is what we want. We don't want to accidentally change something and then, it affects all my other developers. So instead what happens with a container is it has your image and then it performs any changes you perform are with that same copy on write. It's not changing any of the underlying stuff. So if you boot up a container and then you start changing something, it's going to just affect a layer on top. It's not actually changing anything underneath. Okay, which is what you want, because again, if you change something here, it could affect a different image, right? And then you'd have a problem. Okay, so this is one thing that Docker does, right, is it uses this union file system, which allows us to share resources without causing any conflicts, because any changes that are made get performed on a copy on write. Another thing that Docker does, right, is that any of the processes that are run, meaning, I had to go to like localhost 2368. Any of those processes actually occur under a namespace. Okay, meaning that it really just occurs like under its own folder. So you can imagine that, it says that when I do docker run ghost 4.8.0, it says that this is running on localhost 2368. But really what you have to imagine is that's running under like docker / 2368. It's running in 2368 under the Docker environment. Okay, what's the benefit of that? Well, let's say that I already have something on my host computer, right? Imagine you can think of this as like the guest. Let's say on my Mac, I already have something running on 2368. Then this is going to break, right? Because it's going to say, hey, like this port's already occupied, and it's going to run into an error. So by doing this under a namespace, by running all the processes under a namespace, we can make sure that there's not a conflict with the host computer or with any of the other like containers that any of the other services that you might be running. Right? Each of them get their own, each container, every time I do Docker run, that gets its own set of basically processes or namespace to run those processes. Okay, so this is why when it says it's running under, it's running localhost 2368, this is not on your host computer. This is not on your Mac. It's not taking up that port. What you have to do is you have to basically say like, hey, I want to expose this port on my host computer 999 and have it point to 2368 in Docker. So that's what we're saying. You can imagine that this is my host computer. This is Docker. When it says it's running on 2368, it means it's running 2368 in the Docker environment. So what we need to say, and this is walled off from me, so what we need to say is, hey, let's point something on my host computer, port 9999, to 2368. All right? So that's what we're doing here. And we'll see this again. I'm just like showing this as a feature of Docker, but we'll see this again. So now when I don't go to 2368. If I do a breaks, I go to 9999, and that will work. And what's happening is we go to 999 here, and we said that points to 2368 on here. And why does it give us that? Why is it so complicated, right? It's that complication because it wants to ensure, isolation so that, this thing will just always work inside our Docker container, inside this kind of equivalent of a virtual machine, right? We can, as long as we keep things isolated, we can ensure that it works, and then we can be specific about like what we want to expose. So what are the two features of Docker, right? Basically, it's using this union file system. The union file system is, ensures that any changes that we make will only happen with like a copy on write and not affect, any shared software that we've downloaded, right? It will just be particular to that one image or container. And then the other thing that is used is basically like namespaces, right? And namespaces, that's more for the running processes. Again, making sure that there's not going to be a conflict with another process that's running, okay? So those are the two main things. So I'll let you, happy to answer questions about that. But I'll let you move through those readings and then also just like go forward with some of the interfaces of Docker, move through actually interacting with Docker. But before I put you into breakout rooms, questions about this? Yeah, Conwell.
Just a quick
Just a
question
quick question
regarding
regarding
running
running
multiple
multiple
Docker
Docker
images for
images
a
for a
single
single
application
application like
like
we
in the
in the
session
session
today
today
ran
ran
Jupyter
Jupyter
Notebook.
Notebook.
And
And
as you
as you
explained that the
explained that the
port
port
8888
8888
is the
is
one
the
which
one
it
which it
internally runs
internally
upon.
runs upon.
But if there
But
are
if there are
multiple
multiple
images being
images
run
being
for a
run for a
single
single
application like
application like
Jupyter, which
Jupyter,
runs
which
on
runs on
8888,
8888,
Hmm.
how
how
would
would
that
that
get
get
resolved?
resolved? Like
Multiple
multiple
Jupyter
Jupyter
service
service
container or
container or
single
single
port.
port.
Yeah, you can like we can do it here. Like let's say we have Docker, and this one's pointing to 9999, right? So I go to this is my host port, right? 9999 points to this container 2368. So you can imagine I have one local machine or one virtual machine here, basically that I get access to it through 9999. So that's happening here, and then I should be able to do another one. So let's do docker run -p ghost colon 4.8.0, and this time we'll do 9900.2, I think it was 2368. So now here's another one, and for this one we'll go to localhost 9900. Right? So this one's working too. So you can imagine that I have two containers running, right? Each of them are self-contained and isolated. And for one of them, I go to 9999, points me to one of them. For the other one, I go to 9900. That one points me to the other one. But notice they both say, if you look at them, they both say they're running on 2368, right? But that's only inside of their own separate, isolated containers.
So when you
So
say
when you say
containers,
containers,
is
is
it
it
an
an
analogous
analogous
to
to
a
a
Venn
Venn
environment which we
environment which we
created in
created in
Python?
Python?
Here's how I would describe a container. You download VS Code, right? You download VS Code. That's the image, right? You download, you unzip it, right? All those files that you've downloaded and saved to disk, that's the image. The container is, I've now booted up and started VS Code, right? The container is the running of the software, right? The software that's running. When you shut down a container, it's like clicking X on VS Code and shutting it down. If you have two containers running, it's like having VS Code running with one code base and VS Code running with a separate code base, right? That's two containers running, right? The image is we've downloaded all the files to run VS Code. The container is VS Code is now up and running. Does that make sense? Cool. All right. This will take, conceptually, Docker typically takes a little while to get used to. You may not fully feel comfortable with